Hello everyone, my name is Gaurav. I'm a master student in University of Western Ontario. Thank you for giving me this opportunity to present this research at CSE 2024 conference. Also, I'm very thankful to my supervisor, Dr. Robert Mercer, for his constant support throughout this research. This research, which I am presenting today, is titled as Harnessing Pre-trained Language Model for Efficient Move Recognition in Biomedical Abstract. So the agenda of this presentation would be firstly, we will explore the motivation behind the study, discussing the driving factor that led us to delve into the topic of move recognition in the biomedical abstract. Next, we will move on to the introduction, where I will define and explain key terms and concepts on this research topic. Then, following this, we will examine related work, highlighting the contribution of other researchers in this domain and outcomes they achieved. Subsequently, we will delve into methodology section, detailing the data we utilize, the approach we employed, and the results we obtained from our experiment. Finally, we will conclude with a summary of our findings and their implication for future research in this field. Let's start with the motivation. Uh, as you all know, the number of researchers and the volume of publication has been exponentially increasing over the years, leading to a rapid growth of literature across all the domains. Even if we just talk about the biomedical field alone, there are over 33 million citation and abstract of biomedical literature on the PubMed website. This annual increase in the literature presents a significant challenge for researchers. Like when I am searching for a paper of my interest, I need to skim through a numerous abstract and and then I'm able to find either paper is of interest to me or not. This is really a time consuming and labor intensive process. If a abstract is structured, it becomes easier for me to quickly grasp the essence of the paper and determine if the paper is of relevant interest to me or not. Thus, there is a need of efficiency in information retrieval. This can only happen if the abstract is structured. So we decided to work with move recognition. So classifying the abstract sentences into categorical categories like background, objective, method, results, and conclusion will not only aid the researchers but also will support the research in the field of NLP task. We'll start with the introduction. So yeah, in the previous slide I mentioned about move recognition. Move of a research paper refer to the linguistic knowledge unit uh, that the researcher used to express their writing purpose in academic exchanges, such as research purpose, methods, results, conclusion, etc. In other words, like move are rhetorical categories that describe the communicative function of sentences. And in our research, the rhetorical categories that we are trying to identify are background, objective, method, result, and conclusion. In this given a in this research, given an abstract of a paper, our method will automatically identify the move of each sentence into categories like background, objective, method, result, and conclusion. Talking about the recent development in the field of pre-trained language model. Uh, Pre-trained language model has boosted the research in the field of NLP. Various pre-trained models used for text classification has given significant results. Uh, since pre-trained language model are pre-trained on a very vast corpus of text data, and due to the self-attention mechanism, they have an ability to acquire the context of a representation, which make them which makes them capable of giving significant improvement in the existing work. Mm. Talking about our research, the research focus of this paper is particularly in biomedical domain literature, especially RCTs. RCTs, uh, random clinical trial. We are using in this research we are using state of art data set, which is RCMR RCT. Uh, Using this research, we are proposing method for move recognition built using pre-trained models, which has not been fine-tuned over this dataset yet. Uh, so you will get to check the results as well. And we performed experiment using pre-trained models over biomedical data to evaluate the results. We have used this use a BERT-based variance in this paper and compared the results of the RCMR RCT, the state of art dataset, with the popular dataset for move recognition, which is PubMed 20K RCT. Let's talk about the related work. Since I was talking about the dataset, let's start first with the dataset. Scholars have developed corpora for both abstract and full test article for move recognition. In the field of move recognition, there are really interesting dataset, and I have listed this like PubMed 20K RCT, PubMed 200K RCT, PubMed 380K, RCMR 280K. So if we discuss about PubMed 20K RCT, this dataset consists of sentences from PubMed articles and their associated label like move, background, objective, method, results, and conclusion associated with each of either of the sentences. The 20K here represents the number of abstract used to create the dataset, and the RCT is the subdomain. Like this dataset particularly targets a random clinical trials, so you will find a sentence related to the RCT's random clinical trial papers. So similarly applies for PubMed 200K RCT as well. So in this data set, we have sentences from like 20K abstract and particularly focuses on RCT. PubMed 380K consists of is made up of abstract of 380K papers and is not specifically focused on RCTs. Thus, it includes sentences from various subdomains as well. And same goes for RCMR 280K. This is a state of art dataset, and this is built on top of the improvements made over PubMed papers. So there were some improvements like segmentation of sentences in the abstract, encoding, labeling mistakes. So they all worked on that and created this state of art dataset. Let's drive into the methods that researchers have used for move recognition. So numerous noteworthy research articles has been published in this field of move recognition. Traditional machine learning approaches like naive Bayes, conditional random field logistic regression were used previously for move recognition and have given good results. But since these methods required a manual feature selection, which can be quite laborious and time consuming as well, but with the development in the field of NLP, deep learning techniques got popularity and produced superior results. So models like LSTM, CNN, HSLN, RNN improved the state of art and become popular. Again, with the introduction of pre-trained language model, since they are trained on a very wide corpus and as context aware representation, they improve the state of art. So if we talk about the results that pre-trained models have got over PubMed to 20K RC dataset, you see like the fastest has got 89.6 F1 score over this dataset. Implementing AN architecture has got 90%. You can check out this paper. They have implemented that AN architecture, which got an F1 score of 90%. Then there is a model Sen model build present in the paper, which gave an F1 score of 91.1. Along with that, there are various BERT-based variants as well, uh, which are fine-tuned over this uh, corpus, and the F1 score that BERT, Roberta, BioBERT, PubMed BERT got by fine-tuning over this dataset is like 86.16, 86.84, 87.52, 87.70 respectively. Let's discuss the methodology. Um, so as I discussed before, we have used RCMR RCT in our experiment. It consists of sentences and the associated label. Each sentence is a sentence from the abstract of PubMed article, and the label is a move for each sentence. And for the training purpose, we have used sentences from 50K abstract, and for the training for the testing purpose, we have used 2.5K for abstract. So if you just get an estimate, we have like 174K sentences, approximately 174K sentences for training, and 29K sentences for testing purposes. And the move that we are trying to recognize here are background, objective, method, result, and conclusion. The pre-trained model that we are using for the experiment are BERT, BioBERT, SciBERT, PubMed BERT, BioBERT, BART, and Roberta. So among these models, the BioBERT, SciBERT, PubMed BERT, Biomed BERT are model which are pre-trained over biomedical corpus or scientific corpus, and has an understanding of biomedical domain. And using this pre-trained model, we have fine-tuned RCMR RCT dataset for move recognition. Talking about the training process, after every pre-trained model has its own associated tokenizer. So we have passed the sentences of the speech paper through this tokenizer. We got this sentences tokenized. Then we implemented truncated and padding over each sentences to standardize the sequence length and bring it to like 128 length of this of the sequence length. And yeah, the labels are also encoded into using label encoder technique. And we have now the tokenized data and labels, and we have fine-tuned the pre-trained models over this data set. And for the experiment that we used Adam optimizer, and the with Adam optimizer, it was, and the epoch that we used for fine tuning was like 3 epoch, with a warm up rate and training step of 10,000 and 100K respectively. Uh, let's talk about the results that we got from the experiment. The evaluation results in this table reveals the high performance of various pre-trained language model on the test set, with an F1 score ranging from 90.79 to 92.55. Among all of these model, BioBERT is the one which performed the best in terms of F1 score, and followed by PubMed BERT, Biomed BERT, and BART. BioBERT emerges as a top performing model, likely due to the specialized training on biomedical data, followed by PubMed BERT and Biomed BERT. BioBERT is a model which is pre-trained over PMC articles as well as PubMed based article. So that could be a reason for its high performance. Throughout the table, the consistent precision, recall, and the F1 score value indicates their effectiveness in understanding and classifying biomedical texts. The highest performing, the good performing models among this table, table is the one which are pre-trained over biomedical dataset. So what this finding underscore the significance of domain-specific pre-trained language model in enhancing the model performance for specialized text classification tasks. and thus this emphasizes the importance of leveraging domain knowledge in natural language processing model development. If we compare the result of BERT, BioBERT, SciBERT, and PubMed BERT model, uh, which were fine-tuned on PubMed 20K RCT and which are trained on RCMR RCT, there is an improvement of 4.95%, 5.71%, 3.95%, and 4.32% in terms of F1 score matrices. Let's delve into conclusion. Uh, this research particularly focuses on biomedical literature, especially RCTs, and using this method, we are trying to build new approaches, new methods for effective move recognition, and fine-tuning domain-specific pre-trained models has significantly improved the move recognition in biomedical abstract. We have used RCMR RCT dataset, which enhanced the performance compared to PubMed 20K RCT. And among the performances, BioBot was the one which has performed the best. It could be due to um, since it is pre-trained on biomedical corpus. This research also contributes to the ongoing efforts of enhancing biomedical literature analysis by providing insights into the performance of pre-trained language model for move recognition. Um, through this research, we have enhanced move recognition, which will aid in better information retrieval, extraction, and overall comprehension of biomedical literature. These are the references that we have used. Thank you.